Hello everyone. So in today's class we will learn power of lens. Power of a lens. So first of all, what is this power of lens? So let's see the definition. The tangent of angle by which it converges or diverges a beam of light falling at unit distance from the optical center. Falling at unit distance from the optical center. So how it is? Wait, let me draw the diagram, then you will understand. Assume that this is a lens, okay, and now this is the principal axis. Okay, this is the principal axis. Now light ray is falling like this and converging here at this point. This is your optical center, so which I am denoting with this dotted lines. Okay, and this angle, let us suppose this angle is delta. Now this distance is what? Focal length. Agree? This one is what? Focal length, that is f. And this one is what? H. This is height h. Now let us suppose this is a point, this one is optical center O, and this point is B. So now in a triangle OAB, tan of delta is equal to OA by OB. OA by OB. This tan delta. Yes or not? This is what? Opposite by adjacent. Now tan delta is equal to what? H, that is OA, and OB is what here? F. So you got tan delta is equal to H by F. So if H is equal to 1, because already I have written here at unit distance from optical center, at unit distance from optical center. So ये जो है unit distance. So if H is equal to 1, then what we are getting? We are getting tan delta is equal to 1 by F, and this is nothing but what? Power. And therefore power P is equal to tan delta, which is equal to 1 by F. This is what? Power of convex lens. In another simple word, you can write like this: reciprocal of focal length is power. That is P is equal to 1 by F. But in case of convex lens, you can write this definition so that you will understand better. That is what power P is equal to tan delta is equal to 1 by F. And that is the tangent of angle by which it converges or diverges a beam of light falling at unit distance from optical center. Okay, finished. Let's move ahead. Next one. What is the SI unit of power is? So already we have learned this: power P is equal to 1 by F, and therefore SI unit is what? Diopter. It is denoted by capital D or meter inverse. Another is what? Meter inverse, because this is F in meter. Then SI unit is what? Diopter or meter inverse. So power P is equal to 1 by F in meter. That is also equal to 100 by F in centimeter. This already you know. So whenever you want to find power, you can use this. And note point: for convex lens, means another name is what? Converging lens. Converging lens. What is positive here? Focal length is positive. Yes, F is positive. Therefore, P is positive. Second point, concave lens. It is which type of lens? Diverging lens, because it diverges all the rays, है ना? Diverging lens. So for this F is negative. Yes, F is negative, and therefore power P is negative. For which lens? Concave lens. Convex lens power is positive. Concave lens power is negative. Keep it in mind. Okay. So F is maximum. F is maximum for red. For red, and minimum for violet. Okay, F is maximum for red and minimum for violet. Understand? Focal length is maximum for which color? Red color, and minimum for violet color. So obviously power will be minimum for which color? Reciprocal, no? So minimum for red and maximum for violet. Reverse. Power is reciprocal of focal length. Keep it in mind. Okay, finished. Next, now filling up of lens. So filling up of lens means we are going to fill now lenses with different medias or different materials, we can say. Filling up of lens. So in first case how I am filling you see, and in second case how I am filling you can see. So two types of filling, one is horizontal, one is vertical, we can say. So let's see how this is. So for this I am drawing first case. You can see in the diagram. In this second diagram I have filled like this. Okay, and in this now I am going to fill like this. Okay, so now see how many materials I have filled. This is also mu1 only, same, black, same. Let us suppose this is mu2, so I will write with yellow. Okay, this one is mu2, then this one is mu3, and this one is mu4. Okay, and here we have filled suppose length like this. Here you are having Let us suppose this side is mu1 and this side is mu2. So now how we have filled in this case, you see, in this case there are 4 refractive indices, right? So how many number of images? Number of images in this case is equal to refractive indices, number of refractive indices, okay, number of refractive indices. Number of images I am writing direct, that is equal to 4 pi, because 4 refractive indices are there. 4 refractive indices. In this case, you see now, although you have filled 2 materials, but number of images, how many will be here this side? There will be only 1 image. Number of images is equal to 1. Why? Because as only one focal length. So you always keep it in mind, if lens is filled like this, vertically we can say this is horizontal filling, one above other, and this is side by side. Okay, side by side, one above other. Shall I write here? One layer above another, and in this second case, side by side. So if one layer above another we have filled, so we have to see how many refractive indices, how many materials we have used for filling the lens. So if there are 3 refractive indices, then number of images will be 3. When we have filled the layers one above the another. But here, if suppose side by side is there filling, half lens is filled with another refractive indices and a half lens is filled with another refractive indices, but they kept one side by side. Then number of images will be 1. Why? Because focal length will be 1. So keep it in mind this one, right? Okay. Note down this. Okay. So let's move ahead. Now, next is lens immersed in a liquid. Okay. Next topic is what? Lens immersed in liquid. Lens immersed in a liquid. Now, what we are going to do, or which formula we are going to derive, I will show you with the help of one diagram. Okay. So either it is concave or convex. You know how to use sign convention for radius of curvature. That is up to you. But I will show the case of convex lens, right? So let us suppose here is a lens. Okay. Now this side is what? Air. This side is what? Air. Okay. And in the next case, what I am doing, this lens I am going to insert into the liquid. Now I have inserted into liquid means this side you are having liquid Okay. So A bit is what here? Lens in air. This one is what here? Lens in liquid. Now here it is refractive index is what? Mu L. This is what? Mu for lens. है ना? Lens. Here again mu for liquid. 1 minute, I will change the names. Okay, like this. Now let's keep refractive index of this lens as a mu lens. So I am writing here mu of lens, and for this we will write mu of liquid. Okay, mu liquid and mu lens. No, here it is lens only. This side liquid. Okay, this is lens only. No, inside part. So I will write here as a lens only. This side I will write mu liquid. Mu of liquid. Here also refractive index of liquid only. These are the two cases. So first when for A case, what you will get? 1 by Fa is equal to mu lens divided by mu A. So mu air is equal to 1, है ना? Minus 1 into 1 by R1 minus 1 by R2. Call this equation number 1. Next now, for B case, when it is immersed in a liquid, then what you are getting? 1 by FL is equal to 1 by FL is equal to mu lens divided by mu of liquid minus 1 into 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. Call this equation number 2. Okay. Now let's divide 1 by 2. Equation 1 by equation 2. If we will divide, we will get, direct I am writing now, FL divided by FA is equal to mu lens minus 1 divided by mu lens by mu of liquid minus 1. Right? Okay, so this is what the case when lens is immersed in a liquid. So whenever they are asking you formula, or whenever they are asking problems based on this, then you should use sign conventions, and then you can solve the problems based on these models. So for this surface it is R1, for this it is R2. Okay, so you can consider that with sign convention. Clear? Okay, so note down. And if you don't know this, please you go and revise the lens makers formula. It will be very useful for understanding these terms. Okay, so let's stop here for today. Note down properly. Bye.